The purpose of this video is to introduce you to the idea or the concept of glide reflections. Glide reflection is actually a two-step transformation that involves two other transformations that we've already studied in class this year. The first of which is the translation. And the second of which is the line reflection. Now, a key idea that ties these two together is that the direction of our translation must be parallel to the line of our reflection. And I'm going to speak to what that means a little bit later here in our video. What I want to do right now is to take a look at an animation of what this glide reflection might look like. And what's really cool about this animation is that it shows you what happens when the slide is followed by the reflection over and over and over again. For instance, if we start with just a single red triangle and reflect it, and then slide it, reflect it, and then slide it, we can see the pattern repeating itself over and over and over again. So this animation actually involves a couple different slides and a couple different reflections, whereas the ones that we're going to do in class involve only one of each. But again, you can see how the pattern would repeat over and over and over and can be used to create some really neat, interesting, and unique pieces of art. All right, with that said, we're going to be working on the coordinate plane. We're going to start out by looking at this triangle sun. I'm going to go ahead and begin this by graphing the coordinates or the vertices of this triangle. I'll grab my ruler and connect the dots and make this all nicey nice and pretty. And if I take a look at what they're asking me to do here, and like anything else with transformations, I have to make sure that I read and follow the directions. It's asking me actually to do two different things in this question. The first thing that it's asking me to do is graph. And the second task that they're giving me here is to state the coordinates. So I have to make sure I follow directions and do both of those things. It tells me in the problem that my glide reflection involves or uses the translation that moves each point in my figure 9 units to the left, 0 units up and down. You might think about that as subtracting a 9 from each x value and adding 0 to each y value. So I'm simply going to go ahead and I'm going to shift each point in this figure 9 units to the left. And the second part of this glide reflection involves a reflection across the x-axis. So at this point, I'm simply going to take each one of the blue points that I have, and I'm going to reflect it over the x-axis. So this guy here represented point S after I translated it 9 units to the left. If I reflect it across the x-axis, I end up right there. And I'm going to label that new point S prime. This blue point here represented point U, shifted 9 units to the left. When I reflect it across the x-axis, I end up here, my ultimate destination, point U prime. And likewise, this was my representation of N, shifted 9 units to the left. If I reflect that over the x-axis, I end up right there. Again, I'm going to grab my ruler and play connect the dots and draw my new triangle. And then the last thing I need to do in order to wrap this up is make sure I follow through and do what the question's asking and state the coordinates of my new triangle. So my new S coordinate, or my S prime, ended up at negative 6, 1. U prime ended up at negative 3, 4. And N prime ended up at negative 8, 5. I would like to take a minute and take a look at something that's going on in this question. When I translated or slid my triangle across the paper, I slid it in a perfectly horizontal direction. I didn't move it up or down in any way, shape, or form. It was an entirely horizontal slide, or an entirely horizontal translation. When I reflected my triangle across the x-axis, that line of reflection is also a perfectly horizontal line. So when they talk about the direction of the translation being parallel to the line of reflection, that's the concept to which they're referring. All right, let's go ahead and take a look at one more of these on the back side. This one deals with triangle CAT. Like the first one, I'm going to go ahead and get started here by plotting the points that make up the vertices of my triangle. This glide reflection is a little bit different, if only because the line of reflection is different than the first one. This question is asking me to reflect those points across the line whose equation is y equals x. We could go ahead and draw that line on our paper. I'm going to choose to be a little bit more efficient about it, and I remember from a couple days ago that anytime we want to reflect a point across the line y equals x, we can go ahead and do that simply by changing or switching the x value and y value. So the point whose coordinates started out at 1, 2, after a reflection in the line y equals x, becomes 1, 2. Point A, which started out with coordinates 4, 1, after a reflection in the line y equals x, becomes 1, 4. And point T, which started out with coordinates 4, 3, after a reflection in the line y equals x, becomes 3, 4. So that's the first part of my glide reflection. The second part now involves a translation which moves each point 3 units to the left, 3 units down. You might prefer to think about this as subtracting 3 from each x value and subtracting 3 from each y value. So now I'm going to take those blue dots, which can make up the vertices of my triangle, and I'm going to shift each one of those blue dots 3 units to the left and 3 units down. So this is my new A prime. This is my new C prime. This is my new T prime. Now that I've fully completed the transformation, I can go ahead and draw or sketch the triangle. And like the first question, this one has 2 parts. The first thing that they're asking us to do is draw the graph, which we've done. The second part of this is stating the coordinates, which still needs to be done. So to wrap this thing up, I'm going to go ahead and state the coordinates of CAT prime, our new triangle. So point C, it looks like, is at the point whose coordinates are negative 2, negative 1. A prime is at the point whose coordinates are negative 2, 1. T prime is at the point whose coordinates are 0, 1. I would like to take a minute again and just demonstrate to you here that the line of reflection, y equals x, that line right there, that is parallel to the direction in which we slid the triangle. And that is key when you perform a glide reflection. If the direction of the slide and the direction of the line upon which you're performing the line reflection are not parallel, you don't have a glide reflection. All right, I'm going to leave you with one thought and a couple questions to answer. I want you to think about now whether a glide reflection might or might not be an isometry. If you remember from the past few days what an isometry is, then this should be a fairly simple and straightforward question for you to answer. If you don't remember what an isometry is, now would be a good time for you to look that up so that you're able to answer this question. We'll practice more with glide reflections the next time you come to class. And until then, see ya.